So welcome aboard. As I said, we're a small but mighty group here, and we are going to unpack matter today. So this will be your second one that we've unpacked. And so I see we have a question in the chat box saying this is my first session, and I haven't seen the introductory one yet. So for anybody else who's watching the video, the introductory session is found on the ARPDC site. We'll take you there before this video is over to show you where it is. And there's not only the introductory video that Ted and I did, which unpack the terminology that you need to know, but also there's one in there for scientific method for computing science. And so those are important ones for you to watch as well, because we don't unpack the generality of any one of those either in the session. We just launch into it. Those speakers will come in and just really be talking about the unit that we're teaching you on right now. So just watching that introductory video would be very, very helpful to you for sure. Okay, so let's get started. And my name is Chris Sarski, for those of you who are just joining us. I am working with the CART Consortia, and I have the distinct pleasure of working with a fantastic partner who carries his load today on the shoulders of everything that I was looking at. Ted is an amazing, amazing partner to work with. So I'd like him to introduce himself and then we'll get going.
Thanks, Chris. Hi, everyone. My name is Ted Cerrone. I am working out of the Edmonton Regional Learning Consortia here in the Capital Region. I'm coming out of Sherwood Park, and I'm glad you both of you are here. Hopefully what we have will be valuable to you. I know you're very busy at this time of year, and so we want to make sure the session gives you some things that you can take forward with you as you prepare for next fall. Put that finger in the ear, but we'll give you some things so you can maybe feel a little bit more in control after this session in getting ready for the fall. So welcome.
You bet. So before we do the acknowledgement, any of the sessions that we do and have done in the past, we always try to build in some information into that acknowledgement page, whether it's in the form of a static slide like you're going to get now with a resource, or an actual video that you could use with students as well. But it's not necessarily meant for students. It's also sometimes just background knowledge for you, the teacher, that you can integrate some of that into your unit as you start to unpack it. So those will be really, really important for us to consider. So in this case, we're opening with a Venn diagram, which is one of the most powerful tools we have for checking for understanding. So the more that you can use those with students, the better it is, because I can't just memorize factual knowledge. I have to know quite a bit about something in order for me to make a comparison for you. So it's not just straight memorization of two things and then I'm good to go. So that's the power of a Venn diagram. It really allows the students to show us what they understand and what they don't understand. And in this case, what we're looking at is how does the Indigenous knowledge or lens look at science versus the Western world? So we have a way of looking at science, but so does the First Nations look at science quite differently in a lot of respects. And then in others, a lot of the overlap, that we see the same things and we see the same terms and we treat it the same way. So on the left-hand side, you have the traditional knowledge. So for example, you see that holistic sits outside of the circle belonging to the Indigenous lens, because when they do look at science, they look at the land, they look at the world, they look at it holistically. Whereas when we look at it as a part of a whole, part of something that it belongs to. We use the analogy, or have in some other examples talked about, you know, where in a food chain, for example, does the human fit? And we would put the human at the top of the food chain because we're the ultimate consumer and we have the brain. Whereas in an Indigenous lens, the grasshopper and the human would have the same importance. There isn't one more important than the other, because they all have a role to play within the world and within the earth and the sky. And so therefore, there's a bit of a different perspective that could be brought up in class as well, so that all children would see themselves at some point in your classroom studies. So I'd encourage you to have a look at this. The links for the actual article is below, so you're welcome to use that if you so choose. But if nothing else, just to have a look and see what are the commonalities, where are some differences, and then how do those differences impact your planning as you're getting this unit ready. So in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So all of our sessions will be very much the same in the way that they're laid out. We're always going to go back and give you what we call a backgrounder, like what are the pieces that we need to make sure that students understand. We no longer teach science in a box. It's not about moving from grade 4 to grade 5 to grade 6. You have your 5 topics in your grade. And when they're done, they kind of move on to the next grade and do the next 5 topics. And there wasn't always a lot of connection. It didn't really start to get connected until we got into junior high. Now you're very much in a spiral curriculum. So what happens in the previous grade very much informs what may or may not be a key rock or concept that I need to be able to unpack in my grade. And for this particular unit, the 5 and 6 couldn't be any closer together. I mean, you really are going to have to make sure they have a good understanding of 5 before we get into 6. So to bridge that for now, because we know that when students sort of land at your doorstep, and if you're doing this next fall, they won't necessarily arrive at your doorstep with that grade 5 prerequisite knowledge. And so what is it I should maybe pay attention to, do some pre-assessments of to find out what they know, and what do I need to sort of build on before I kind of launch into the outcomes that I see in my particular grade. We'll look at unpacking your understandings for grade 6. Understandings are the biggest and most important piece of your curriculum. The knowledge and skills and procedures kind of build on that, and how do I unpack that understanding? And so we'll look at that. We'll use that language of surface and deep, and Ted will go through that, but that's really unpacked in the introductory video. We'll look at different kinds of assessment questions. We'll give you some sample ones that could just be basic surface level kinds of questions that you might want to ask versus where they have to start thinking a little bit more independently and on their own. And then some resources that might be helpful to you as you're building your unit, whether it's in terms of books, links, or YouTubes that could be used for information to gather or grab information from the students to see what they've learned. So we're going to go back to grade 3 and pick up just a few, and just be aware of a few things that happen there. One of the terms that we see starting early in the curriculum is the term property. And it comes up right in kindergarten and goes into grade 1, but it really builds through to become really critical as students start working through in the upper grades. And so therefore, we really want to make sure that students are clear and that they understand what properties are and how those are going to work, and what are the terminologies around that, and what lens am I looking through. So in this case, they talk about materials, they've talked about change, they've talked about, in younger grades, they've talked about defining what is a property and an object and learning the difference between the two. And then in grade 3, we really kind of start to unpack things a little more intently. And we look at what are the states of matter of these objects that we're doing, or materials that we're looking at, the different materials. And if you don't think students know what a material is, then we'll unpack that in just a bit. So the different states of matter, we talk about how materials could be used. So their uses, their purpose may also determine what product is going to be used to make them. And then we also look at what are some changes that could occur, what are permanent changes versus reversible changes, right? So if we talk about freezing water, we can turn it into an ice cube, but I can let the ice cube melt and I can turn it right back into water again, which is really a phase change that we're talking about in grade 6. So in grade 3, there was a very informative YouTube that we gave teachers as resources. And again, a YouTube doesn't have to be you stand up and deliver, tell me all the terms, give me all the info, and then we watch it. You might want to watch it first and just ask them open-ended questions. You know, what did we learn? What are the different materials? Can you name them? Let's make a list on the board. So draw from them the important pieces as opposed to just giving it to them, and then just sort of moving on into grade 6. So this one really unpacks all the different common materials that students should know about, but maybe they don't think of them in terms of a material. And then it even has places in there where you could pause. At the end of each material, pause the video, ask them questions, let them give you more examples of what they've heard, just so that you can do that assessment piece about, yeah, they got it. They understand what this is all about. So properties of those materials, we talk about things like flexible, soft, slippery, shiny. Some of those are words too that are descriptive words, and they need to know the difference between what is a property and what is a descriptive word for that property. So we want them to be careful that they're not mixing and matching some of those. So again, any of these that you see here that you think, well, I don't know if my kids might not know that, you have access to every grade. So again, when we show you where the resources are, we'll show you also where to find grade 1, grade 2, grade 3, grade 4, anything that you need that you can go in and find. So again, we've given you this sheet in here, just talking a little bit about materials. They work on testing materials for their properties. These are not hyperlinked, but the links are up here. So you can just grab that link, and then any one of these you can go into and grab as needed. More importantly, states of matter. That's a really important one because they do need to know that, and that becomes really critical even for what they're going to be doing with you. So the grade 5 teachers, same thing. We said if they don't know states of matter, then that's where it's a good starting point as well. And this is a great video. It really gives them lots of information. And there's some guiding questions that you might want to ask them to listen for. They could watch it again. What did they see? And for you, because you're going into phase changes, we could even use this again and ask them, you know, where did you find in this video that there was a phase change? So that would be another way to go back just over the same video that they've already seen. We have a card sort in here, and we've been using sorts quite a bit in living systems as well as occasional ones in matter, but more in living systems, where they go through and they can cut these out. So you have a master sheet for this that you can grab. And they cut out the hexagons, place them in the correct pouch. And that pouch is from a foldable that's made in grade 3. So you can get all of these from the grade 3 folder. They're all housed in there. And again, it's just an interactive activity. If we think we need to do a little bit more work, need to do maybe some experiments, not necessarily always hands-on. Some of these are demos, but that helps me to go through and kind of connect each of these descriptors. So the color coding is fitting to these. So here's your descriptor, and there it is. These are all hyperlinked for you so that you have access to them. Okay, and so we have some books on states of matter. They talk about solids, they talk about gases, states of matter. And then this is just a resource. They look at food, right? You see food every day. So how does that work, right? Another book that we have is Solids and Liquids. That's the title of the book. So these are just some recommendations if you're looking for some to have in your in-class library, not necessarily as a class set. There are some that are really strong books, and they would be ones that we would certainly point out to you that, you know, if you wanted a couple more in the classroom, this would be a good one. And I'll show you where some of those are because they will come up in this particular lesson as well. States of Matter, this is a sort of a graphic organizer science magazine. It's done as a cartoon, but it's powerful. It's just straightforward science is what it is. They do it through Max Axiom, who's kind of the superhero that goes through and solves the issues of investigation or whatever he's looking for. So again, that's another one that could possibly be considered. But grade 5 really is a rock for you. You may want to go back and do a lot of what's in grade 5. So we're giving you a lot of the slides, not every one of them, but a lot of them. So really just talking again about what is matter. It's made up of small particles, talking about how those particles move. And that's really another piece that they're going to unpack here is the infusion of heat. How does heat make that molecule move, change arrangements? And then when we talk about the physical properties of matter, these are words that they are unpacking in grade 5. And so those are really important too, for them to really have a good understanding. So at the bottom on the floor here, you see a lot of the different areas that should be covered in grade 5 as I'm unpacking those different concepts. And so that'll be a component to have a look at. Some of those also overlap and are the same things that you need to cover in grade 6. So even though you might feel like you're going back and reteaching some of grade 5, a lot of it is in your grade 6 curriculum too. So you're really picking up outcomes at the same time for grade 6. Particle model matters. So these are lots of videos, but again, we said to the grade 5 teachers, this one here in particular is great. It's actually written for older students, and it's done by a university professor, but he does such a great job of just showing how the particles are going to change within matter to reflect the different states, and makes it very real. And I think that's going to be really important for students to see that. So I would start with this one, maybe go to this one. You could ask them questions again, make sure that they understand it, but that's very much where you're going, because that's exactly what your references are in your cusp as well. So talking about how a solid is packed together, how our liquids put together, and how our gas is put together. So this is really the crux of what they're doing in grade 5, and really understanding that a little bit more. I did include in grade 5 sublimation and deposition, but that's not part of grade 5, but would be really appropriate for the grade 6 as well. There is an interactive hands-on. So if you want to take me through and teach me a little bit about how does it look different in a solid versus a gas versus a liquid, this is an interactive lesson, which basically covers all of grade 5. It's not a one-page lesson, it's a multiple page lesson. And at each stage, they also have hyperlinks in there where you can show the students modeling of what's happening when we're talking about how the molecules change when we add heat, for example, in a particular situation. So we ask them some open-ended questions here. So again, you could look at those. Maybe those are things that you want to have a look at. And then unpacking. Sorry, whenever we put hyperlinks in and start, they start on their own. So in this case, these are key terms that they needed to learn in grade 5. They're the same key terms that they need for grade 6. And so again, you could actually just launch right in here and use any of these as needed and still be meeting your grade 6 outcomes. So all of these are information, really information gathering. A lot of them have demos in them so students can see it actually happening and to make some connections with that, but that's not enough for them to really know, right? They still have to go deeper than that. We have additional ones. How do you measure some of these? Like, how would you measure volume? Not necessarily length times width times height, right? Not that they they won't have already done some of that in math, because they will. In grade 6, they will have been doing that. But that's not the point here. The point is for them to conceptually understand what it is that volume actually is. And how could I measure? How could I measure the volume of a rock if I don't have anything that I don't have a formula that has an odd shaped rock? What can I do? Well, I could fill a beaker with water, measure it, then I could throw the rock in, see if it goes up, and get a sense, right? So those are pieces that we can talk about when we're doing this. So again, some of these are demos. It talks to them about different tools. I would challenge you to ask them to provide you with other tools that they measure. What else do they use that would be helpful?
The final form of measure.
So again, when we talk about Chemistry for Life, this is another resource that you can use. This link here will take you to these 3, but also to these. So then again, you have to decide what it is that your students are going to need additional information on. We have a gizmo, and we're going to talk about gizmos later, so I won't do anything here, but there was a gizmo that we showed in grade 5, and this one is not a scavenger hunt, but it's a mystery that they have to try and solve, where they find an Egyptian coin and they're trying to figure out what the properties of that coin are. So it really tied in well to the kinds of things that we were talking about in grade 5. Okay, and then again, find another situation where we measure volume. Maybe they bake, right? Maybe they do some baking and they use measuring cups, right? Just what else do they do? Are there things on the farm that they use for measuring? Just so their heads are starting to think in those terms. Okay, so let's move on. We've already looked at that one. I might take those out again. So let's go to grade 6. And then before we talk about any specifics, let's unpack that terminology again that is in the intro video. So I'll turn it over to Ted.
Thanks, Chris. Those of you who've already watched our session on living systems, the one prior to this, you'll notice the presentation format has changed a little bit. In that session, we took a look at this phases of learning like we are now. It's the basis of how we're organizing our session. But we did a little bit different, and I'll go through the surface or the phases for you really quickly, just as a reminder. And then I'll explain maybe the difference in what we're moving forward to with this particular session, and probably the ones moving forward. When we talk about phases of learning, we're talking about the order in which we often move our planning and our learning activities to help kids learn deeply the concepts and skills that they're expected to learn from that grade. The surface level is where we often spend most of our time. It's really just learning the basic information, the knowledge, the facts, and learning some of the skills at that level. When we talk about surface level learning of concepts, we're talking about a full, not just the definition, but we're also talking about learning about the finding examples of it, non-examples. So it's really those facts, or memorizing the definitions and using them in that sense at a very surface level. But we need to move beyond that and go to the deep. And the deep, again, is where we link those concepts, so the individual pieces of knowledge together into something kind of an understanding. And that understanding becomes something a little bit bigger. And as Chris mentioned, it's the understanding, it's that the statements in that middle column of the curriculum that we're really driving towards. And it's composed of all the little bits of knowledge in the surface level, all the concepts. And we get students to demonstrate their understanding of those things through the use of various skills words, such as comparing, contrasting, representing. Maybe they're discussing something or explaining something. And so we're looking towards getting that deep understanding of things. And then when we get students to demonstrate that understanding or explain that understanding in a increasingly novel context or unfamiliar context, we know that they're beginning to transfer. And it's really at that transfer phase that we're really looking at assessment too, right? We're giving them a new situation. We've worked to get them a deep understanding, and now we're going to assess, using an unfamiliar situation, the level to which they understand what we're hoping that they do. And so in what we did in the previous session with living systems, was we took all the concepts, the entire organizing idea and skills, and we gave examples of how to teach those all at once, and we moved to deep. And then we did all the understandings in the organizing idea all at once. We're going to change up a little bit and go cusp line by cusp line. So we're going to take a look at cusp line number 1. What are the surface level things we need to do there, the deep level things, and then some activities. And then we'll take cusp line number 2 and do the same thing with it. So moving on then. When we're looking at the surface level again, we're looking at those individual concepts, the individual ideas that are built in, and those are all located in they're used in the understanding, but their definitions and examples are housed in that knowledge column in the curriculum. So we can go beyond the slide into the next one, Chris. Chris mentioned before that the concepts this is aspiring curriculum, and we see the concepts all over. So you'll certainly see that in the next slide. The next slide shows all the different, should show all the different, we'll get there.
There we go.
Oh, there we go. This is the grade 5, all sort of the key concepts in the grade 5 curriculum. I'm not learning matter learning organizing idea. I'm not going to go through that. I'm actually going to layer on top the grade 6 one, and you'll see it's the same as the grade 5, just with some additions to it. The dotted line additions to it are what really comes into play in grade 6. And so it's going to be helpful to look at both this slide probably, or this concept map, to really get a sense of what grade 6 is going to. And in order to read this, you have to really download the PDF that we want available for you and kind of read it carefully. There's some connecting lines that help explain what happened, how these ideas are connected. So to get a sense of where we're going, kind of sum up what Chris has mentioned so far, we begin at the top. We can read that particles of matter. The theory or the model holds that matter is composed of particles going down, and those particles are held together by attractive forces. And the strength of those attractive forces determines the state of that matter, which can be a solid, liquid, or gas. If that attractive force is strong, like we have a solid, and the movement that happens is that the particles just vibrate in place and are closely packed together in terms of an arrangement. When we get to liquid, the movement is a little bit more ease. There's a sliding past each other with the particles, and there are spaces now in between the particles. And when we're at a gas, when the attractive forces are very weak, the particles are in constant motion in all directions, and there's large spaces in between the particles. That's really how the model works. If we move to the left, we see that matter is composed of or has physical properties, and the ones we're looking at, and as Chris mentioned, properties were looked at all the way from kindergarten up to now. We're looking at the physical properties in at grade 5 and grade 6, of course, of mass, density, volume, and compressibility. Those basically the grade 5 course. And the grade 6, we're adding on the new layer with the dotted lines. And if we read across from matter, we know that when it comes to matter, it typically experiences contraction or expansion based on heating and cooling. And that heating and cooling affects the movement and arrangement of the particles. If we heat things, we'll get expansion and space in between the particles. If we cool things, the spaces will get closer together and move from gas to liquid to solid. So we're really introducing more of the dynamic look of the model of particle model theory by giving it the heating and the cooling to move from one phase to another. And you can again see how states of matter, which is introduced in grade 3, really comes into play as well. So we're talking about phase changes there. And of course, that heating and cooling, there's a bit of talk on water. That water does not fit that descriptor of expansion and contraction with heating and cooling. It's the opposite. And of course, that heating and cooling really impacts our tool design or design of anything, such as the thermometers. We need to know about heating and cooling when we're designing things. We'll take a look at some of that. So that in a nutshell is what we're looking at in grade 6. It's all of that.
A lot of grade 5.
It's a lot, yeah. So a lot of grade 5. And again, this is just another graph of how you can see the concepts in this matter unit, especially progressing through the grades. You can see on the far left, we see properties are first introduced in kindergarten with senses. They're the observable properties, and moves all the way from measurable properties to testable properties to physical properties in grade 5. And again, those physical properties are referenced again in grade 6. So once again, we go when we're beginning our look then at how to unpack a cusp line. We got to look for the concepts first because they're the building blocks to everything. And what I did was here, when we're doing that, if we take a look at the understanding, we see particles and speed and distance and heating and cooling are highlighted there. So when we're talking about speeding and distance, we're really talking about particle movement. And heating and cooling, we're talking about temperature, and you'll see those words show up on the left in the knowledge column. You see heating there, reference to speed, move faster, move slower, references to space, which is distance in between. So we're talking about, and we also see phase change in the knowledge component, state of matter, volume, mass at the end as well. So in order to fully understand that understanding, a lot of those concepts are going to come into play when we're trying to create that understanding. So as you do, number one, look at the understanding. What do you really need and what's going to support you in the knowledge? And then when you do that, then you can sort of imagine this is what you're preparing. So we go to the next slide. So if we're working at that surface level, then we're going to pull out all those concepts that students need to know or need to be familiar with, and make sure that you understand those before we move on and try to work with that understanding and introduce the idea of heating and cooling. A simple, some pre-assessments and thing, as Chris mentioned, will be really important at this point. Most of them, if they've been through the grade 5 curriculum, when they come to you after year 2 here, they should be very familiar with all of those. If not, there may be some reteaching that needs to be done. And certainly when you're teaching this, if they haven't had any of the grade 5 in the pilot, then a lot of pre-teaching might be done here. But again, pre-assess, they may know a lot of those concepts already. But besides the individual ideas, concepts, we know that if we take a look at the far right, we'll see that we're going to have the students demonstrate what they know by discussing or explaining or conducting an experiment. So there's some skills that they need to know. You can go to that slide, Chris. Yep. There's going to be some skills they need to know because we're going to have them demonstrate what they know and understand using those skills. So when I'm talking about a skill or procedure, I'm not talking about the entire skills and procedures statement. I'm talking about the particular skill. The ones that show up in this organizing idea is discuss, explain, investigate, relate, or connecting ideas, designing, predicting, hypothesizing. I'll talk more about the skills in grade 6 a little bit later, but when we're talking about teaching at the surface level, we're kind of planning, that backwards by design planning. We're saying, oh, we're going to assess our kids using these verbs. So we want to make sure before we can get going too far in things that at the surface level, we want to make sure they understand how to discuss things properly, what designing means. They understand what a hypothesis or prediction is, and they can make them and so on. They know what a controlled experiment is, an investigation is, before we let them loose to use an investigation to demonstrate what they know. And so that's again, shown on this graphic. We're still at the surface level. If they don't know how to conduct a controlled experiment, we'll give you some suggestions of how you can do that, for example, and we'll teach it at the beginning just to focus on the controlled experiment. We're not going to use the course content and particle matter theory or anything like that, or particle model of matter to teach them that. We're just going to focus on some simple experiments where they can learn about how to conduct an experiment, and that's at the surface level. And once we know about all those good things, then we're going to move forward. But right now we're going to stop and give you some examples of how you can introduce at the surface level the concepts and skills that are going to be needed to develop the understanding in this particular cusp.
And a lot of the things that are highlighted in yellow there are just cut and paste actually from grade 5.
Yeah.
So right, it really is, as we said, you're going to have to go back and reteach some of the grade 5s, but you're still meeting all of your outcomes for grade 6 at the same time. So don't panic that you're going to run out of time.
So again, we just a read list of all those things. A lot of them they're probably aware. They probably know what a general idea what speed is, what distance is. They may need a reminder about volume and mass, but they'll be familiar with temperature and heating and cooling. And they need to be reminded of particle. But there's some things that if you're not too sure about some of them, here are some activities that might help you out a little bit. I think, Chris, we've got a few here. Oh, okay, I'm keeping going.
Yeah, no, keep going. You're good.
All right. Well, this isn't one of the concepts. It kind of is, but if you notice, one of the verbs there was to relate ideas together. And that idea of building relationships between concepts and identifying the connection between them. You'll see the verb and the skills and process that connect or relate will often be the word. And so there's a concept attainment activity. We're not going to go through it now, but it's one that it can introduce to you if your students aren't familiar with building relationships between ideas, what that means. And it actually gives the first steps of building a concept map, because we know a concept map like the one I just showed you are really taking those individual words, and I put the words in between the arrows showing how those ideas are related. And it's a really good way for students to develop their understanding or to show their understanding when they can show relationships between those words. And because I know through the backwards design process, they're going to need to show me some relationships between these concepts, and we'll show you in a deep activity what we mean. It's going to be we're going to want to make sure they can do that before we get them to do a more deep activity where they're building relationships. So this would be done at the surface level, this introduction.
And I think it's really important, if you didn't catch when Ted said, this is not directed at your outcome. This is to teach me what a concept attainment is first, so that you can come back later and say, do you remember how we did our concept attainment for? Now we can apply that to our outcomes. This is not specific just to grade 6.
I'll go through a concept attainment lesson, and it has that specific target because it's a specific process. But again, here's some more. Chris is going to share with you some ideas of how to build those other concepts that were on that list.
And so when we look at some of these, like no, I won't. I don't think we have time for it today, but this screen really gives you a lot of starting points. And again, if I was going to use a video, which I do use, I also like case studies. Like I like to approach it from less stand up and deliver and more, I'm going to give you some info. I don't really care right now if you don't know anything about it, because I'm going to ask you questions about what you did learn from it, and then to gather sort of and garner where the students are at. So the states of matter and phase changes, this is, we'll just watch the beginning parts of it in just a second, but I did put a note here, is of all of the resources you have on here, this is where I would start first. If you're going to use this as sort of an eye-opener, teaching piece, want to get going, because it really does tie together the grade 3 and the grade 5 stuff at the same time. So we'll just go into this one just for a little bit, and then I'll stop it.
Oh, hey, you know, the world is much more connected than we might realize. What? You can't hear me? Okay, you stay there, I'll come to you. As I was saying, the world is much more connected than we might realize. This rubber ducky, this water, the air we breathe, it's all made of matter. Matter. It's all made of matter. And today, that's going to be the only thing that matters, the states of matter. And I guess I could have just walked around to tell you that. Okay, I'm gonna go put some dry clothes on. I'll see you in a minute. You, me, this little puppy, this ice cream, dark charts next week, are all made of matter. Matter can come in 3 main phases. A solid, like this plant, liquid, like this water, whoops, or gas, like the air in this balloon. Now the cool thing is, matter can actually change its phase back and forth between these 3 phases, solid, gas, and liquid. Now in a solid, the particles of matter are packed extremely close together. They're so close, that's why I can't go through this solid wall. Particles are too close together. Now in a liquid, they're spread out a little bit more. That's why earlier I could swim through this pool. The particles are far away enough from each other that I can move through them, but they are close enough that they still slow me down. Now in a gas, the particles are really far away from each other. That's why you can move through a gas so easily, and you can do fun stuff like this.
Okay, it goes on, and I guess the reason I wanted to show that to you is because it does offer a lot of the background knowledge that we need, but on the same token, it's a little bit more real than some of the other ones that we had, and I really think it's a good starting point for you if you haven't done that work with the students yet. The other piece to that is, and it's going to come up later, is I have a bit of a bias at everything that we're teaching the kids about where how the molecules are displayed. Can they represent it? Can they model it? Whatever. Yeah, they can. They're going to always show them in this sort of graphic form. So hopefully later on show you another option for maybe how we could make that a little bit more real for the students. So in here you have lots of resources that talk about phase changes. There's some labs. This is an excellent lab if you want to see the phase changes, and they're quite well described. So again, if you don't have the materials that you could do the lab yourself, well, then you've got an opportunity here. And the same information here, the nice part of it, he's got the temperature hooked up to the computer so that we can watch it change as time goes on. But down here, it's basically an enlargement of this. It just takes you through. There's no talking on it, but the students see the temperature changes as things happen. So again, it's just an information page for you. And we'll go into the concept attainments.
Right. Just recalling that one slide, we pulled out all the things we're going to teach at the surface level. We do know that for the students to demonstrate their understanding of the individual concepts and of the understanding, when we get to that point, they're going to have a discussion, they're going to do controlled experiment, and so on. So when students will need to know what that is as well. So how can we teach that at a surface level? To begin with, the idea of an investigation, which is a controlled experiment, really begins at grade 1 and more specifically grade 2. But if we students may know what investigation is, but I just like to go through. If you go back to that slide, Chris, sorry. I just want to go through quickly a concept attainment lesson with you, so you get just what it's about, because you're going to have access to a lot of concept attainment lessons. What they're meant to just introduce the idea of a concept. We can do it in many ways. Like we could just give the definition to kids and our students and do it that way, because sometimes that is the most that's an effective way, and it's a time-saving way, and so on. But sometimes if you want to have students think about something a little bit more deeply and practice some other those critical thinking skills, such as hypothesizing and observing and things like that, and making logical connections, these are useful approach as well to introduce a concept. They're not going to necessarily memorize it forever after this, but it's concept attainment lesson is going to be giving them a feeling of a interesting way to be introduced to that concept. Anyway, just a note there that I'm going to use a lot of images. It might be good to print them out if you can, and make them big if you're going to use something like this to introduce an investigation, if they need to know, if they need to be introduced to what an investigation is. This is meant for younger grades for sure, but you could fix it up to suit your students, or if they think they can use this, then by all means. So the way a concept attainment lesson works is that students are given a lot of examples of the idea you have in mind. My idea that I have in mind, and I wouldn't tell them, but it's it's an investigation. What is that? So I'm going to give some examples of investigations, and in this particular case, I'll just call them some yeses, and some things that don't fit what I have in mind, which is an investigation. And you can see the example is the yes is an example of an investigation. I lost my puppy. And I wondered where she was. I looked around the house. I found her in my bedroom. Or a non-example is we went to the mall. I was able to get this delicious ice cream cone. It was the best tasting ever. And if it's difficult to do this on a slide deck because the examples disappear. What you want to have is all the yeses and nos kind of together, so that students can look at all the yeses and see what they all have in similar. What do all the yeses have in similar that make them a yes? And why don't the no's fit in? What are they missing that doesn't make them a yes? So again, another example, I was feeling well, asked my parents what was wrong, and they took me to the doctor. He examined and said I had the flu. And if you could see all the way along with all these, the yeses are going to be, someone has a question or something they want to get an answer to, and they find the answer to it. And that's essentially what an investigation is. So there are more examples and non-examples in a concept attainment lesson. You can see them showing up here. And then once you get to a certain point, you say, I'm going to give you some other examples here. You maybe have an idea what it is, but here's some examples to see if you can, based on what you think it is, where would they fit? Which is the example here? Which is a yes? Is it story number 1, story number 2? And they would give their reasons why would they think it would be without giving it a name. And then as a class, you'd come through a decision and classify those as either yeses or nos as well. That's the next slide. And then once we that is in the next slide, we would determine that together. Once you get far along and give enough examples and non-examples, then you provide a definition. And a simple definition is what an investigation is, what people do to find answers to questions. And then there are some more activities to just explore and have students come up with examples and non-examples of what investigations are. And that's how a concept attainment lesson kind of works. They're all a little bit different, but they simply go through examples, non-examples. Students take a look at what are the similarities through the examples to develop that concept, because that's really what concepts are, right? We're just categories that we have a lot of examples filling in. I do want to just mention about it. Now we know what investigation is. How do we conduct it? First of all, don't click on that link that I'm going to talk about, Chris. But at grade 2, they list the steps of an investigation. You won't see them listed in grade 5 at all. You have to go back to grade 2 to see the list. What grade 5 does is they add on to that list by talking about a controlled experiment. So, Chris, if you can click onto that grade 5 controlled experiment 1. I've included here the steps. Generally, with something like a procedure, I prefer something called the direct teaching approach, saying, here's what it is, here's what we're going to do. You guys know what investigation is. We've covered that concept. And so number one, you want to do is define the skill. What is investigating? You can see that I also included a definition for a controlled experiment, which is it's a certain type of investigation in which we have a variable that changes and one stays the same. We can scroll down, Chris. So that defines some of the things. We know that there's some key concepts, again, investigation, scientific investigation, and controlled experiment. And if we take a look at number 3, what you always want to do before you do this, make sure you have the steps clear to yourself. The 7 steps there that you see are from the grade 2 organizing idea or scientific method organizing idea. You won't see those 7 steps in the grade 6 curriculum or the grade 6 scientific methods organizing idea. Now I'm going to have you go back to that one slide, Chris. Just scroll back up to where you were at step number 3. So grade 2 has those 7 steps there. You notice the 3 bulleted parts. So we're talking about independent, dependent, and control variables. Those are introduced at grade 5. So those won't appear in the grade 2. But for grade 5 and grade 6, then when controlled investigations or controlled experiments are used, that's where we start throwing in the idea of independent and dependent variables. And then scroll down one more. Before you go off and start going through this with students, you want to make sure they understand some of the key concepts related in. I'm sure they know what questions are, but we want to make sure they know what are good questions. They're going to need to make predictions, but in grade 6, that changes to hypotheses. They're basically the same thing, but the word prediction disappears after grade 5 and it's replaced with hypothesis. So I want to make sure they know what that is. What's a dependent variable, an independent variable, and so on. There will be activities for you to some concept attainment activities for a lot of these that you'll have access to later on the resource package that accompanies this video. And so that's really the steps there. We ask questions, we do an experiment, and we investigate it. So that's there to help you out. And there we'll talk about scientific methods a little bit more later on, but those are things you want to make sure that at the surface level that they understand the process and have practice doing a controlled experiment before you have them do one at the end of this cusp to show their understanding. Chris, I'm going to have you go leave this one and just quickly go to another link that I have available there. If you want to introduce a controlled experiment to your students if they haven't had one at this time, then there's an example there that goes through the steps, asking the questions, deciding what the independent, dependent variable will be. It's very simple again, so they're focused on the steps, not the content. So, and it should say instead of marble, it should be a little car, I think is what it was, and I'll change that a little bit later because I changed it from marble to car partway through, but I didn't change it in the upper part. I'll make that correction. So it's a very simple procedure to introduce that to kids. Once they know what a hypothesis and a prediction is, once they know what investigation is, once they know what a conclusion is, then we can put it all together and say, well, here's the steps into an investigation. And it goes through all the steps, what to do when you're just testing the distance that the height of a ramp makes on the distance of a car that rolls down the ramp. So, the manipulated variable is going to be the ramp height. The dependent variable that we're just going to keep checking all the time is the distance, and how does that change when you change the height of the ramp, which is the independent variable. And it just introduces those kids to those concepts there. It might be one you want to try. But if you're going to do something like this, you notice again, we're not talking about any of the content, about particles or matter, because we're focused just on the process or the skills involved with this. Thanks, Chris.
Okay.
And again, if there's a discussion going on there, again, we want to make sure that if it's at the start of the year, at the start of a unit or start of a cusp line, that we know we're going to discuss some things later on. And so what is the discussion? And there's some discussion formats there. You'll see a link there to discussion checklist. And that checklist is developed by using the statements that were in the competencies, which are listed in the New Learn Alberta or identified in the New Learn Alberta website with the curriculum. In the competencies are communication and collaboration competencies for Div 1 and Div 2. So what I've taken is combined the Div 1 and Div 2 things that I thought would make a useful checklist for that grade. If you want to use that, you can. And of course, we're going to talk about a discussion with students. So we're going to be discussing things and we'll review what a discussion is and the purpose of them and some expectations. So when students do a discussion in any of those formats or a one-on-one discussion with you, they're familiar with it and they'll be better off demonstrating what they know and understand if they're good at discussing things. Once we've got all that, we go to the deep. So we've gotten rid of all, because we know what they do, but a lot of it's just going to be review and they understand what those things are. And now we look at a couple of things. And there are really three deep things to look at here. One of them is that now that we know what particles are, we're going to help students understand that particles change speed and direction or movement from each other when heated or cooled, or particles change speed or movement depending on the temperature. In other words, is another way to look at that. So that's the first one we're going to look at. The second one we're going to look at is you notice it's kind of located in the knowledge part there, but we could see three ideas related there. It says during a phase change, the volume of the matter may change, but the mass remains constant. And there's really two things, if you see where it's connected with the skills and procedure, because that's how we're going to get kids to understand that. They're going to do controlled experiments to prove that mass of a substance stays the same after a phase change. So that would be a deep level thing that we're going to do, and they can come to the conclusion after doing that experiment. And then again, deep number 3 is just talking about the phase change of matter. That how the phase changes of matter when heated or cooled. Explain the phase changes, using the particle of matter theory. So it's putting together concepts from the particle model of matter and phase changes such as solid, liquids, and gases, and combining those and say, how does all that stuff relate? And so those are really three understandings that we want our students to walk away with, are those three things. And you notice in the red box, I say, when you're planning for the deep den, try to match up the skills and procedures statement to the understanding, because that's going to give you some learning activities and even some assessment activities that will be it'd be the foundation for those activities when you want to move into that level. Chris, I think we can move on. So we're looking at the first one, which is the understanding is what's the relationship between particles, speed, distance, and temperature. How are they all connected? And so we can do that by doing some investigating here. So we can go to the next slide. That'll give an example of one activity you might want to do to experiment with that, or to at least investigate that. There's a short little video there on how a hot air balloon works. And we know that hot air balloons talk about all the things that have to do with phase, not necessarily phase change, but the heating of particles, expanding, and then becoming less dense as they expand. So there's a short little video there. And after that video, we may want to have kids take all those words at the bottom, and that's why I talked about relationships at the surface part of this discussion, is put all those words in a concept map and explain why they're related to help explain how the hot air balloon works.
And the nice thing about this video is it also will show them in dot form, of course, but it does show them the differences in the particles and their behavior within. So it's rather than just talking about it, there's actually a visual that goes with that.
And when students know those individual concepts, they will be able to put them together in that concept map. The other one is, what's the relationship then between phase change and mass? In other words, does mass change with a phase change? And that's really the question's been asking. And again, we can investigate that by doing a little example or a little class investigation. And there's one that you can take a look at that may work. I believe it works with wax, melting wax, and then measuring it when it's solid, measuring when it's melted, and then measuring the mass again when it's back to solid, and then coming to the conclusion. It takes you through that investigation process. There's a sheet there that'll help you or the students work through that experiment or investigation. And finally, that third deep understanding is, what's the connection between phase change temperature, and the particle model of matter. There are a bunch of little concepts related to each of those, to phase change, particle model of matter, and with temperature. And so an activity that might get them to make the connections between all those things is to give them these things here. It's a hexagonal thinking. Students should be given these little hexagons. And when you're doing this activity, it's just really when you connect a hexagon together with something, students will need to demonstrate why they are connected together. For example, we could see state is connected to solid, liquid, and gas. And the explanation to that is that a solid, liquid, and gas are the different states of matter. And when we go from solid, we can go from solid to liquid, and we could also go from liquid to gas, typically is the way the phases of state changes work. And so that's what you'll want to have students explain as to why they made the connections when they did put them together. So at the end of the day, there's lots of individual concepts and understanding or little concepts associated with this that the students could put together. So what I did was I divided them up into 2 groups, and you could see them on the next slide. There's set 1 that you would give to one student to put together and to see if they can arrange those in some meaning. And there's another set that another student could work on. The difference between the 2 sets is that one focuses a bit more on the movement and the speed, and the other one focuses on the position of tightly packed or spread apart. Some of the ideas are similar. So at the end of the day, when you ask the 2 students to come together and put them together into one big group, they can eliminate some of those along the way to put them all together to create one big understanding, hopefully explain the understanding that was in the question that was put forward to them.
And this one is just another version of this, but as I said to you before, and I was saying to Ted, I struggle sometimes with when we try to give kids theory only, right? And we're saying, when we have a solid, we have these tightly packed molecules that vibrate a little bit. And then when we add heat in, and then they start to move further. And then when we give them more heat, then we get a gas. But it's always these dots and pictures and animations that we're showing. So this is not to say that the P's are the molecules, but what I wanted to do was have a visual for students to see what happens. So yes, there's a phase change here. If I have frozen peas, they're embedded in water, frozen, it's ice, they're sitting here solidly, and then I add heat to the matter. I'm going to obviously melt the ice. I'm going to start to get water in there. I'm going to start to cook my peas. But the purpose of really grabbing this was for kids to see, as those peas unthaw, the ice melts away, I start to see the peas actually reacting like the particles of matter in the water would. It's the water that's moving them, the particles inside, but it was more the visual that I'm looking for here. I'll have to find a better way of getting that visual up here, but just so that you can see it, right? And even if they did this in a science lab and you had a beaker on the side and put some frozen ones in there, they can see them moving around within that over the heat as it's boiling, so that they get a visual of what does it mean when you add more heat? Well, it starts to move away from being tightly frozen together to have got more space to be, and if I keep boiling and boiling and boiling, eventually I see the water disappear, right? So that was the only point behind this. I look for real things when I can find it. If we can find it, great. If we can't, well, we do the best we can. But if there's other things that you can think of that would give students that model, and food's a great one, right? They can be cooking in the kitchen with their parent and look down and see the connection that's happening in front of them. Can they connect that understanding? So we'll move on.
Our next cusp line then is to we moved from the second cusp to third one. In terms of order of presentation, I think the third cusp comes in more handy, because we're talking about when things are heated and cooled, they expand or contract. And the really important thing to look, those are the 2 key important concepts here, really, is expansion and contraction. We could see a lot of the stuff on the left, and there's really just some factual stuff that students need to know about water, that it does the opposite when it comes to heating and cooling compared to other materials. And then the other important thing that is to come out of this, that when we design things, we have to consider expansion and contraction. If you take a look at the understanding part in this slide, the top understanding that most matter expands when heated and contracts when cooled is the one that's with this cusp line. What we did was we brought in the understanding from the second cusp line to put this together, because at the end of the day, too, expansion and contraction of matter can be the basis for design. And you can see how that links directly to the stuff when we're talking about design of bridges and roads and so on. Cusp line 2 really talks about the design of thermometers. And we think that's really, again, an example of a basis for design. So expansion and contraction can be the basis of a design for sidewalks, bridges, and roads. And then we'll see later on, we took a look at cusp line number 2 for thermometers as well. And again, you could see then those are the 2 key concepts that students need to understand. They're fairly basic. And then, of course, they're going to be conducting investigation. We already covered that. And then explaining and hypothesizing. And hypothesizing might be something new. And so we may have to introduce that at the surface level. So really 3 things at the surface level to introduce here. There's when it comes to design, because if students will see later on, they're going to be designing things, and what does it mean? There's an example there, and the design information comes from grade 4 computer science. They're introduced to get like scientific methods, they're introduced at once, but the design process is something that is expected for students to bring forward. So they understand the problem, they plan, they create it, they make an artifact, and they do troubleshooting to see if it works. So just thought to throw it in, you so you're aware, when you see the design, it comes from grade 4 computer science. Now, Chris, went through a lot of concepts with the surface level in the first cusp line. Here's 2 more: expansion, contraction. Notice they really didn't give a definition for it in the cusp line. The getting larger, getting smaller component was kind of missing, so I added it in here. But to help you and your students, maybe more importantly, your students, organize all these individual concepts, because there are a lot of them, as you probably sensing here. Holy cow, how many ideas are there? You may want to have students develop or keep track of their individual concepts on either one of these templates. You could use one for each concept. The Freyer model is one of them that you may be familiar with. Just a quick look at it, Chris, and we'll move away from it. You can click on that. The other one is fairly similar, where you put the word of the concept in the middle. For example, expansion. You put it in the middle, the definition goes there, the attributes, what is expansion, and what are examples of it. Non-examples would be contraction. So you maybe do expansion and contraction on the same sheet, for example. You could put in other things in there, such as density. What is density? Because students need to know what that is at this level as well. And any of those other concepts that go into here, they can each have their individual sheet, and you can use that as a template if you want. And again, it's providing those examples and non-examples that really show where the kids understand the concept. And again, the next slide, just if they're new to the word hypothesis, there's a prediction, concept, attainment, activity, and I'll just change a little bit for grade 6 to move it into hypothesis, because that's what they use in hypothesis. But it's basically a prediction, right? Though, so that helps them to introduce that word. And then, so this cusp line for a deep, again, we're talking a couple things here. Again, the first thing when you go to deep is say, okay, I know where the students are, what they need to know at the surface level. At the deep level, I could take a look at my skills and procedures and say, okay, here's where they're connected. So when it comes to talking about the expansion and contraction of matter for the basis of design, we want them to explain it. That skills procedure is there for. How can you explain that? And then again, they're connected to the orange things, which are the understandings in a sense. So you can use that. You'll notice I have some blue things there. Again, that's just some pretty surface level stuff. That water is frozen and expands when frozen, and contracts when not frozen, and just some things to test that knowledge out, or to demonstrate that knowledge. But the key thing to understand with this one is the expansion and contraction is the basis for design. We have to consider those things when we're talking about design. So we'll take a look at some deep activities that can help understand that. You can skip that, although there's some design problems that we have, and then those things are explained here through Chris's slides and examples here.
So with location, this slide really just looks at the importance of the expansion and contraction. Do they understand that? And answering kind of the question, like, what is it? Why is it important, right? And this is an excellent starting point for them, just to introduce those two terminologies and make sure that they're clear on them, plus providing them with some sample ideas. So if you're going to actually do a Frayer model with them later, we would be looking for them to come up with other examples, not the ones that they've already seen and that we talked about. We want newer ones to see if they can dig a little bit deeper and make those connections. So this is a great one to start with. But then again, talking about, you know, the gaps in bridges, why do we see those gaps? What's the purpose behind them? Same thing with sidewalks. When we talk about sidewalks, when we talk about when you put a container in the freezer, you know, why do we only fill it part way full? We don't fill it right to the very top and put a plastic lid on it and then find out later when it comes back, the lid's been popped off, right, as it's frozen. So having those examples, and those are easy examples that they can do in school. Those are things that we can put in there and say, I'm going to put a tight lid on it. Let's see what happens when it freezes, or it breaks, or it cracks, or whatever. So again, these are just places that you can go to for resources, and again, to start off that conversation.
And one of the skills and procedures statements in this CUSP line was to conduct an investigation to demonstrate that liquid in water is denser than solid water. Again, it's sort of a knowledge thing, but how can we test that and see that happen? There's a video that goes through a bit of an experiment that you may want to write up in your own terms with the students, and do that either as an individual activity where they could practice writing their own instructions and their own gathering materials and so on. And basically, because one of the steps in the design or the investigation process is that students design an investigation, so they can model it off of this. There's no words. It's pretty simple and straightforward. And then have them reach a conclusion at the end of the day. After they make a hypothesis, they can make a conclusion. We'd want to make sure that those words are used at the bottom, that those words are used in their conclusion when they discuss this and what they found. So basically, it's just put an ice cube in the oil, and it's gonna, when it melts, it sinks to the bottom. And why does that happen, basically, right? And it's the relationship between, or the idea that water as a liquid is denser than water as a solid. And students in grade 5, again, they'll take a lot. They take a look. They took a close look at what density is already. So that wouldn't be one you have to come back to. And so we skipped over the 1.2, the second CUSP line, to do the third one first, and coming back here, because that second CUSP line is pretty much all just surface level stuff. It's just a lot of facts about what a thermometer is and the Celsius scale and so on. The only thing that may be close to being the understanding part is just being able to explain how a thermometer works using all the concepts from phase change and particle of matter, particle in the matter theory or model that we've been looking at. So we've got some activities at the surface level here.
So again, this talks about water, the unique properties of water, but it also gets into that specific CUSP now, where we're talking about how does the thermometer work, and moreover, can they make their own thermometer? Like, what would that look like, and what would I have to do to design that? And again, it gives them an opportunity to write up their actual investigation and their experiment that they're going to do. So, and how do they, you know, what's their hypothesis as far as this is going to work, and how is it going to work, and what's the prediction as to where it's going to go? We don't necessarily have to have graded values on the side to say what it reads off of. What we want to know is, how does it work, and how does the thermometer, with the expansion of the fluid inside of it, to move forward, move up and down, right? So again, you've got an example here that you can go through with them and then let them try one. It's a pretty easy one for them to do. And again, you've got some other ones too, infrared thermometers. They may not know what that is and how that works for measurement. So that might be just an information piece that you want to do. And then using it to measure temperature, which isn't new. They would have done something like that in grade 3 as well. They've learned how to read the thermometer and make comparisons between imperial and metric measurements on there in grade 3 as well. So not all of that will be completely new to them. There is an information piece in here about class. It has lots of activities that you're able to use that relate to this, but if you want to do any of the self-scoring, then you have to purchase a membership for it. All right, let's go.
And again, I'm going to introduce representation here, making representations. It wasn't one of the lists of verbs listed in the skills and procedures for this particular organizing idea, but representing is still a way that students can demonstrate their understanding. So if you go to this slide, shows what representation is and some different representations students can do to show their understanding. And so the reason I included that is because when we go to the deep part of this one, where we have kids explain what the how a thermometer works based on what we know about what we've learned in this organizing idea, we can do this next activity then. And that's simply taking the thermometer, which is the deep thing. We can go to the next slide, Chris, and explaining, make a representation to show how a thermometer works. So use some graphics or something, explain how expansion, contraction, heat and cooling, and play a role and particles play a role in how a thermometer works. So that might be one way for them to show their understanding of how a thermometer works. When it comes to assessment of all these, really a lot of the activities that Chris and I shown, are in a sense those formative assessment activities as well. As they're working, we're doing that triangulation assessment piece of doing observations, conversations, and looking at students' products. A transfer activity is simply giving students a whole new context to which to work in. They could be used as summative assessments as well. So we could take some of those same things, do an investigation or conduct an experiment. We can have them do those again independently using different materials in a different situation to again, maybe work as an assessment piece as well. And that we always have to remember that the skills and procedures, just the verbs themselves, not the entire statement. The specific skills and procedures are the things that students do to demonstrate what they know and understand. So we give them those things to do for an assessment piece for us as well. And that's why I want to just quickly show you the next slide here. It's just if you take a look at the left, those are the most commonly used verbs or skills in the skills and procedures part of the curriculum from grades K to 3 in all the organizing ideas, the entire science curriculum. And you could see I didn't finish the grade 6 one, but I did the same in grade 5. The grade 5 words you see there are all the ones that are most frequently used verbs in the skills and procedure statement. You could see the similarity between the grade 5 and the K1, 2, 3 one. And once again, just in this organizing idea, you could see similarities between what students do here and what they do in other grades as well. So the point is that when we're assessing, we choose a verb, and that verb, they're going to use that to demonstrate what they know. They can discuss, they can explain, they can investigate, they can make observations, report back to us. What we can do is give them practice and use all these different ways for them to demonstrate what they know and understand. So when we create our assessments, all these verbs can come into play as long as they've had practice, again, doing those things.
Exactly.
And so if you want to do transfer activities, that might be true, and it might be too much of a shift for students. But when we think about the STEAM engine and how it works, it really it takes into consideration everything we've learned in this organizing idea and puts it together. There's some other things introduced in the video that at the bottom that they include the word piston and cylinder, but it's meant for an elementary audience. And it may be good. And at the end of the day, once they take a look at a couple of videos of what a steam engine actually looks like, and if they see when we know what we're talking about, the concept of steam engine is on the left and how it works is described at the bottom. And after that video, maybe students can answer those questions. What ideas from the particle model of matter are evident in the video, and then use some of their knowledge to respond to the other statements there. One potential transfer or assessment piece, because once again, it's a brand new context, but the same understandings are being applied, and that's what transfer is really all about.
And if you're a teacher that likes to have centers in the classroom, then using this model as one of your centers. So here's one. Now we've got another one over here, another one over here, where they've just got novel, maybe 2 or 3 videos that they could watch, or whatever it is that you have available, where they would either cycle around or choose, right? Students always give us their best work when they have some input into what they're going to look at and talk about. And so if they get choice as to which one they're going to demonstrate for us, you might get even more buy-in. So again, it gives them an opportunity to be involved in that piece.
Hello, everyone.
Hello, Mr. Moose.
We just threw this one in just because thought was interesting. It talks about certainly about expansion and that gas expands in volume. But there's no heat involved in this one, so it's not directly related. So what we're looking at is, this might be an interesting one to throw at your students, challenge them to practice their hypothesis making skills, because the hypothesis is making a prediction based on the scientific knowledge that we know. So students know about particles and changes, and that gas expands and they're loose particles. So how they can, their knowledge, hypothesize which of these 4 bottles after they've been shaken will be the hardest to indent. Just a fun thing. But again, doesn't have anything to do with a change in state because of heat. It's got something else. But this is just a practice making their hypothesis and say, why do you have that hypothesis? And they should explain that they have this hypothesis and bring in some of their understandings from the particle model of matter in their explanation.
Well,
and then,
I can't wait to see how that goes. I love the idea. I laughed when Ted found it, and I said, yeah, this is what every teacher wants. Let's take 4 bottles of pop in the classroom and shake them up and see what happens. But you know what? It's a great activity. Kids would love this. I mean, you could do it outside. Right? Again,
it's just that you'll want to see when they make their hypothesis because the hypothesis is, well, why are you making that hypothesis? What information do you have? So it's a good one to get kids to explain what they know and would their hypothesis make sense based on what they know? And it probably would, but it wouldn't be the right hypothesis, because the next page explains why. Probably the one with the least pop, and it might just be the hardest, right? We won't go through that, but that explains it.
And for those of you, depending on your age, you may remember when 2-liter pop bottles first came out, and the way they called them exploding pop bottles, because there was a huge time frame in which when you transported them home, if they tipped over, many of them exploded in cars. And so there was a big, should we have these bottles, blah, blah, blah. And there were lots of things that came into play there, but much the same as what we're doing here. So you could even ask them that question, why do you think that even happened? Okay. So we do have some additional resources for you. Again, these are just add-ins. They could still supplement any one of your lessons. The phases of matter. These are interactive 8 lessons. They have built-in quizzes and writing assignments. They come from PBS. If you haven't subscribed to PBS, I suggest that would be a good place to go and sign up. It's for free, but they have such great educational opportunities for us to tie into, especially if I'm looking for things like a demo, a science lab, and I don't have enough equipment, or I want to set up different centers in my room, but I want them to be uniquely different. Well, this would be one place that I could get enough information to create that center and not have to go out and buy a ton of things to go along with it. So in this case, I've just sort of shown you where they link in. And again, you've got a heat transfer one here where it talks about convection, conduction. So a little bit outside of, but somewhat still within what we want to talk about. Physical sciences is an entire unit that you can go into. So you would stop. It lets you go through and choose all kinds of different pieces, but you obviously are going to want to stop at mixtures because we're not getting into that for grade 6. There's also a book that has been sent to me. It comes from, it's called Science Flex, F-L-E-X. I'll show you the cover in just a second. This is a wonderful resource, and it ties in so brilliantly with grade 5 and 6 in the matter unit that we're talking about right now. So that might be something to have on hand in your school. This is the name of it right here. It doesn't appear to come digitally, but this was 2017 in some of them. So it might be now that it is available. And there's your ISBN number if you need that. So another book, when we brought, first of all, just comparing matter. And again, when I talked about the Venn diagram being so important, we have shown this now for the grade 3, 4, and 5 teachers, but more for grade 3 and 5. So there's different states of matter. And then how do they compare a liquid solid, right? My common points in between, how does a solid compare with a gas? And then more importantly, how do all three of them, like what all three of them have in common? So that's kind of understanding that particle theory matter, same thing. So here's another visual, again, of the different components of our molecules under different states. And then how does the increase in temperature affect what's happening inside? And it kind of goes to the pressure question as well. So, you know, and that minus the temperature change in the pop bottles, you could easily ask them that question, that what do you think would happen in each one of these if we could heat them? How would that change every one of them? Now, obviously, we're not going to, because they're plastic bottles, but that gets to that understanding of, do they really understand how that works, and what do they think might happen? And that comes from a book called Changing Matter. So these two that I just showed you are actually two books that would be great to have on hand. This Changing Matter one has worked well for grades 3, 5, and 6 consistently. And it covers everything in it that you possibly need in yours. So it would be one to maybe consider having on hand. The other piece is the gizmos. So in the pilot series, when we did the pilot, we had gizmos join us. We had a representative come and join us and explain, first of all, what a gizmo is. So if you're not familiar with gizmos, gizmos are interactive platforms, and they definitely could be used as a summative piece. It could also be a model in which they are testing out their theories, an actual experiment, but they're very interactive and they're very, very deep. So you don't just sort of find one on the list, and I didn't have time to make, you know, the lesson that goes with this. There's lessons already created for it. There's worksheets that you can print out that go along with it, or exploration sheets that go along. But you as the teacher really, really need to go through the gizmo before you assign it to the student, because there'll be questions that come up, and it's very, very good and they're very deep, but you actually have to experience it yourself before you go through it. So the point of having them meet with us was to really just sort of identify what are the gizmos that they have right now, and they have them numbered. The numbering is not relevant to Alberta numbering in any way, shape, or form, but this is just their numbering. And it explains to you what it is, but it tells you which change it reflects. And there was a whole bunch that they had. So in the series that we had at the time, we actually had all the participants sign up. I'll share that with you in just a second. It doesn't cost you anything. Gizmos are on the new Learn Alberta site, and you can go and access those without any additional sign up, other than just your teacher login that you need to access them. But the Explore Learning also has additional, about another 300 gizmos on their site, which we can still access for free in the same way you would in New Learn Alberta. And so when you come to their sites, you basically have to choose. You can go into Alberta and you can choose between mathematics and science. And you can see there's all different grades in here that you can choose. It's not just for younger ones. A lot of these that are written here are actually at lower grade levels, and that was the purpose of them going through and actually fitting them into our current curriculums, our new curriculums. So there's lots to choose from on there. And as we said, the numbering is not necessarily the ones that we want, but when we talk about the physical world changes, what we've been talking about right now and here, we have a number that we can grab. So we have met with, and here they are, just transferred in for you. You can just look at the slide deck at any time so you can see which one it belongs to. We used to have 6 different cusps in this one in the draft series. So although you see a 4 and a 6, you'll find that those actually fit into 2 and 3 as you go through them. So this is sort of where we're at right now. Gizmos is again, ExploreNet Learning, sorry, is again hosting a number of sessions. They put them in August. When you go to one of these sessions, what it will do is they will give you your login to their site. You still can go to the New Learn Alberta. It's just you have more at the other site to grab as well. So you can go to one of these sessions. You will get registered. They'll send you a login and a password. And then once you've done that sort of 30-minute walkthrough with them so that you know where to go, then you're away. You can access it from anywhere at any time. So this is a slide of their bulletin that they have sent out right now across the province. It may or may not reach your school, but the link to it is right here so that you can go in and you can click on if I want to register for an August session, or if you have any questions or you want to get information about getting your own login, like all that stuff. So just click this on, that'll take you directly to this sheet actively, and that gives you a chance to get in there. In addition to the resources that we had for books, we're also providing, this comes from the Ontario Ministry of Education. They recently changed their science curriculum as well, and their teachers asked for a common rubric. So we had some teachers ask us if there was a rubric that they could use by division. And we said, this is one that we're saying it's not a must do, it's just saying it's here if you want to use it. Then by all means, a copy of this you'll find in your folder as well. But you can also just go to the Ontario Ministry of Education and you can just pull one off directly off the website there. But it has 4 different levels. This is just a snapshot of one row. It's about 3 pages long. So it gives you, if you're looking for something common at the new program, that will give you that opportunity. And lastly, we have computing science. We have another member of our team, Ange Deering. She is an educational tech teacher that works with Wetaskiwin Regional Public Schools. And what she has created for you is specific to your grade, to your organizing idea. For each one, she will go in and say, you know, how would I take the grade 6 outcomes that I have to cover that we just talked about in all these cusps and infuse computing science into the mix of all of this. So she'll give you very specific examples. Here's the recording that you can watch, and she also shares the slide deck with you, so you're able to use those. You'll also find those inside the folder. When you go to look for our stuff, you'll have that in there as well. Do you want to talk about scientific methods, Ted? Oh, you're muted.
I did it again. Just very quickly, this should read grade 6 scientific method summary. And just a reminder that at grade 2, we look at the procedure. Grade 3, we add on the controlled experiment to the procedure. And grade 6, your grade, the emphasis is really on explanations. In other words, after all the investigating is done, we gather all this data, and that data becomes evidence for the conclusion we make or the scientific explanation that we make at the end of the day. So that's focused on explanations and data and using it as evidence. So just so you know that that's there as well. And we do have another person joining us. Nicole Amaru is going to be doing some videos to help unpack scientific methods for each grade, including grade 6, and providing some ideas of how they can be integrated again to the various grades. So that's coming your way as well to help you understand how to do that particular organizing idea.
Okay, so before we leave, I just want to make sure that everybody knows where to find the materials. So in the chat box, I see Ted already put it in there, but if you want to, if you didn't grab it before, please do so. And we're just going to go to that right now. And I have it up on my screen. And so when you come to the ARPDC site, you're going to come to the original site, and you want to go up top here where it says new curriculum resources. So click that on. And when you do, then you'll have sort of a selection of boxes here that you can go into. Not everything has new curriculum yet, but we're in science right now. So when we click on science, I can also just put it in here, but I've clicked on science, so I'm already there. Now I can put in my grade that I want to work with. If you don't put the grade in, it doesn't mean you can't find your things. But when we post things to ARPD site in general, it's always what the most recent item that was created is put on the front page. And then you'd have to scroll through to find what you're looking for. If you go through this process, it will minimize that search for you. So here we are in grade 6. And so you have some information. These are the concept professions that Ted was looking at. Here's your key documents that are in the introductory video that we talk about. We have some other ones that have been posted. Scientific methods, you have that's Nicole's general presentation, which is absolutely worth watching. And then again, when we talk about when you see something like this where it says draft on it, that's from the pilot. So be careful if you grab something from there, it is no longer linked to the new curriculum. So you would have to deliberately go back and double check it. As we post new ones, so for example, we're going to be posting matter probably tomorrow morning, then the old matter will come down so that we aren't getting confused and people aren't realizing sometimes that they're the same. Okay, so this one will come down. This is the draft one because the new one is already posted in there. So this is where you'll find your resources and your materials that you need for science. Okay, so let me just stop our video here, our recording.